Mule Studio is a user-friendly and powerful, Eclipse-based tool that allows you to easily create Mule ESB flows, and edit and test them quickly without a deep knowledge of Mule configuration. What is a Mule Studio? Mule Studio is a powerful, user-friendly Eclipse-based tool. Mule Studio is an Eclipse-based tool that has three main components: a package tree, a palette, and a canvas. Mule ESB easily create flows as well as edit and test them in a few minutes. Mule Studio currently in public beta. It is based on drag and drop elements and supports two-way editing. Advantage of Mule Studio: you can easily create Mule ESB flows, and edit and test them quickly without a deep knowledge of Mule configuration. One of the main advantages of this tool is that you can build Mule ESB flows in a graphic environment. It is based on drag and drop elements and supports two-way editing, config XML and UI editor. Three main component of Mule Studio: a package tree, a palette, a canvas. First of all, we will discuss the package tree. Package Explorer tree. The package tree contains the entire structure of your project. Here you can see the Package Explorer tree. In this Package Explorer tree under src/main/java folder you can store custom Java class. src/main/resources folder you can create a graphical flow. Application folder you can store the Mule deploy.properties file. src/main app folder contains the flow of XML files. src/main test folder contains flow-related test files. Mule Project XML contains project metadata. You can edit the name, description, and server runtime version used for the specific project. JRE System Library contains the Java runtime libraries. Mule Runtime contains the Mule runtime libraries. A palette. The second component is palette. The palette is the source for accessing endpoints, components, transformers, and cloud connectors. You drag them from the palette and drop them into the canvas in order to create flows. The palette typically displays buttons indicating the different types of Mule elements. You view the content of each button by clicking on each button. If you do not want to expand elements, click again on the button again to hide the content. A canvas. The last component is canvas. The canvas is the graphical editor where you drop elements from the palette to build your flow. See the image. You can see how to drag the elements from the palette and drop them into the canvas. Inside the editor you can create one or more flows. Using the Global Elements pane, you can configure global Mule elements. Here you can see the different type of palette components in Mule Studio. Here you can see the different type of endpoint. Generally, endpoints send and receive data, and are responsible for connecting to external resources and delivering messages. First we will discuss FTP endpoint. FTP endpoint. This endpoint read file from FTP server. This endpoint carries all the information for an FTP connection. The host and port values are required. File endpoint. This endpoint reads a file from the file system. Generic endpoint. This endpoint is used to dynamic way to configure an endpoint using Mule expressions and specifying paths. HTTP endpoint. This endpoint is used to process HTTP requests or responses. JMS endpoint. This endpoint is used to send or receives messages from a JMS queue. VM endpoint. This endpoint is used to in-memory queue that allows you to integrate different flows or services in the same Mule config. Here you can see the different type of the components. First we will discuss the component. Component. This component is used to invoke Java component. Components specify a Java class as the service component, or configure a reference to an implementation in a container such as Spring. Echo component. This component is used to echoes a message payload to the console. Logger component. This component is used to performs logging using an expression that determines what should be logged depending on the logging level. REST component. This component is used to make a REST service available via Jersey. REST is the formalized architecture of HTTP based on the concepts of resources, links, and a uniform interface. It uses the HTTP protocol. SOAP component. This component is used to make a web service available via CXF. Here you can see the different type of transformers. Custom transformer. This transformer is used to transformer that delegates to a Java class. Object to XML transformer. This transformer is used to convert a Java object to an XML representation using stream. Script transformer. This transformer is used to use as a script to transform the payload. Transformer ref. This transformer is used to reference as a global transformer. XSLT transformer. This transformer is used to transform XML using XSLT. XML to object transformer. This transformer is used to convert XML to Java Bean graphs using stream. Here you can see the different type of filter. Custom filter. This filter is used to user-implemented filter. The standard filters handle most filtering requirements, but you can also create your own filter. To create a filter, implement the filter interface. Exception filter. The exception filter is a filter that matches an exception type. Expression filter. The expression filter evaluates a range of expressions providing different type of evaluators such as XPATH, JXPath, OGNL and also a custom evaluator. Message property filter. The message property filter allows you to add logic to your routers based on the value of one or more properties of a message. This filter can be very powerful because the message properties are exposed, allowing you to reference any transport-specific or user-defined property. Filter reference. This filter is used to reference to a globally defined filter. Regular expression filter. This filter is used to filter that applies a regular expression pattern to the message payload. Wildcard filter. This filter is used to filter that matches string messages against wildcards. Payload filter. This filter is used to filter that checks the class type of the payload object inside a message. Here you can see the flow control. Flow control refers to message processors that control the destination of the messages in a flow. The splitter uses an expression to split a message into pieces, all of which are then sent to the next message processor. Here you can see the two type of router. One is all router, and another is choice router. All router. The all message processor can be used to send the same message to multiple targets. Router that sends message to all routes. Choice router. The choice message processor sends a message to the first message processor that matches. Router that routes messages based on expressions. Round robin. Iterates through a list of two or more message processors, sending successive messages to the next message processor on the list. When it reaches the end of the list, it jumps to the start of the list and resumes the iteration. Splitter evaluates an expression which determines how it sections a message into two or more parts. The splitter then sends each of these message parts, in sequence, to the next message processor in an application flow. First successful sends a message to the next message processor within a circular list of processor targets. Here you can see the scopes. A scope is a context in which other components operate, for instance, an asynchronous block. It's a way of grouping components to achieve a goal. All the components in an asynchronous block are executed asynchronously. Here you can see Cloud Connector. Salesforce. The Salesforce connector provides an easy way to integrate with the Salesforce API. This allows users to create flows which can query, create and update information in Salesforce. Twitter. The Twitter connector provides an easy way to integrate with the Twitter API using Mule flows.